This video shows you how to create and debug an ARMv8 project for Linux kernel. The video also explains various OS awareness capabilities. The Linux kernel debug provides you following capabilities. You can view program source code, memory, registers, stack frames, or variables. No kernel changes are required. Supports multi-core debugging. Supports MMU awareness. You can view system information such as kernel information, threads list, and modules list. Supports loadable kernel module debugging. Supports various scenarios such as attached to a running Linux kernel and attached to U-boot and start Linux from U-boot. MMU awareness detects the point where MMU initialization is done and computes and applies the relocation offset. The user is not aware of the two debug configuration settings, before or after MMU initialization. Before beginning with the Linux kernel debugging, ensure that you have met the following prerequisites. Download and install SDK EAR5.0, configure Linux kernel, build image, build Linux kernel, and get the images. To debug Linux kernel, launch the CodeWarrior IDE and create a Linux kernel project by importing the Linux kernel image. To create Linux kernel project, select File, New, CodeWarrior Executable Importer from the IDE menu bar. The ARMv8 project dialog box is displayed. Browse to the Linux kernel image to be imported. Once the executable is selected, the image type is auto-detected based on the symbols table. You can override the value by selecting another type. Click Finish. Note that the new project gets populated in the projects view of the workbench, and the newly created debug configuration appears in the Debug Configurations dialog. Click the Debugger tab. Set up the target connection configuration. Ensure that the checkbox options Enable OS Awareness and Use CodeWarrior script for Linux Awareness are selected. Click Debug. No symbols are available as while being in U-boot. The Linux has not been started yet. Set breakpoints at key points of booting process using the console window. Underscore text for Linux kernel entry point before MMU initialization. Start underscore kernel for kernel setup after MMU initialization. Resume the debug process. Start the Linux kernel. Entry breakpoint is hit. Only one core is displayed in the debug view. Linux kernel awareness automatically applies the symbol relocation corresponding to mapping before MMU initialization. Step into the breakpoints. Resume the debug process. Start kernel breakpoint is hit. Using an internal event point, Linux kernel awareness detects the point where the kernel initializes the MMU and applies the corresponding settings. Click the OS Resources view. You can see information about Linux kernel version and build time. You can check if target image version matches the ELF image version. You can also see information about Linux kernel modules and Linux kernel threads. Resume debugging. Print information about the processors detected by the Linux kernel. You can see all the 8 cores running in the debug view. Resume the debug process. Insert a kernel module at the command line. Click the OS Resources view to view information about the kernel module and threads. You can see the state of the threads in this view. In the console view, set breakpoint at Linux kernel function chmod_common. This function is called when a user from the root console changes the file permissions using the command chmod. Create a new file. Change the permission for the file. CodeWarrior stops at the breakpoint set at the function chmod_common. Terminate the debug session. For more information about CodeWarrior for ARMv8 features, please visit ARMv8 page at nxp.com, where you will find all the related documentation, or contact your local representative. Thank you for watching this demo.